Okay, we are going to learn about isotopes. Okay, what are isotopes? Okay, isotopes are atoms of the same element. Okay, but they same element means they must have the same number of proton. Okay, if you have different proton, then they are different element already. Okay, but they have different number of neutron. Okay, let's look at this example, isotope of carbon. Okay, carbon has total of 3 isotopes, and the 3 isotopes are, the name is carbon 12, carbon 13, and carbon 14. Okay, in order to refer it as carbon, the proton number must be 6. Okay, that one don't change, because according to that, isotope means you must have the same proton number. Okay, it means that carbon 12, 13, or 14, whatever carbon that you have, they are going to be, all of them are going to have the proton number, which is going to be 6. Okay. But the different thing that you are going to have over here is the name itself. It's suggesting the mass. Okay, the mass number is different. Okay, so the mass number is going to be 12. This is the common ones. Okay, the common ones. Okay, normally carbon we always write 12. Okay, but there are isotope which is going to be 13. We have the isotope which is going to be 14. Okay, so we call it carbon 12, carbon 13, and carbon 14. Mr. Gopi, if you ask, Mr. Gopi, how come you have 3 carbon? It's not possible. It is possible. Okay, it is. Okay, in nature, there are different variations, of carbon. Okay, like just take it as, they have carbon, they have twins. Yeah, so they are the same, but if you go in detail, they are not fully the same. Yeah, which is going to be, they have different number of neutron. Why different number of neutron? Okay, let's actually look at one by one. Yeah, so if you have carbon 12, if you look at 10, proton is 6, electron is 6, neutron 12 minus 6, which is 6. Okay, and if you look at this, Pen, proton is 6, electron must be the same. Okay, 13 minus 6 is going to be, how many? 13 minus 6. Terence?
7.
Okay, so if you have Pen over here, proton is going to be 6, electron is 6. 14 minus 6, Kimberly?
8.
8. Okay, if you look over here, the difference that you can notice over here, proton and electron, they are all the same. Okay, they are all the same. The only thing that is going to be different over here is the number of neutron. Okay, you can see the number of neutron is different, and this different number of neutron gives rise to different mass number. Yeah, because nuclear number is different. Yeah, so that's why isotopes, they have the same element, that has the same number of proton but different number of neutron. Now my question over here is, I have mentioned to you chemical property, depends on the electrons earlier. Now, I just want to put this question out. Naomi, do you think that isotopes have the same chemical property or different chemical property?
The same.
The same chemical property. Why the same chemical property?
Because it's the same element.
Same element. Rather than saying same element, what else the same over here?
Same proton number.
Same proton number, but that doesn't mean that they must have the same chemical property. Earlier, remember just now I said that chemical property depends on what? Like for example, group 1, all of them share the same chemical property. Group 2, they have the same chemical property. Why? Because the number of valence electron, is going to be the same. Okay, so it means whenever we are talking about chemical property, we are talking about the electron. Okay, this one, all of them, okay, same chemical property. It means that we are talking about number of electron. So if you have the same number of electron, which is here, okay, all these number of electrons are the same, it means that they have the same chemical property. Okay, it means they have the same chemical property. Why? Okay, because okay, they have okay the same number of electron. That is the reason. Okay, if you have the same number of electron, they will have the same chemical property. Okay, so it means that what is important over here, isotope. Okay, what is the definition? Isotope, same element with the same number of proton, different number of neutron. Okay, but they have the same chemical property. Now, if chemical property, if you are having the same, how about physical property? Okay, can you give me some example of physical property? Okay, so Chris, let's see, Michelle, Christabel.
Sir, could you repeat the question, please?
Okay, Michelle, okay, if you have, okay, isotope have the same chemical property, I just told about physical property. So can you tell me what are the examples of physical properties that you know?
Example of physical properties that what?
Yeah, that is the question. Okay, what are the example of physical property? Is mass a physical property?
Yes.
Yes, mass is one example of physical property. Okay, apart from mass, okay, is there any other physical properties that you know that you can relate to here?
Melting, boiling point.
Yeah, melting, boiling point is a physical property. How about density?
Yes.
Yes. Okay, all these, okay, density, okay, mass, and so on, they are all physical property. Now, physical property, okay, I just want to check with you guys now. Henrietta, do you think that isotope will have the same physical property? Based on our discussion just now, okay? Example, okay, maybe Michelle, can you actually list down what we discussed just now? Okay, what are the physical properties just now?
Mass, melting, boiling point, density, freezing point.
Okay, melting, okay, then density, okay, all these are the example, okay. So now, Henrietta, can you tell me, do you think that, okay, the isotope will have same physical property or different physical property? I think this is already enough for you to make the guess, Henrietta.
Repeat the question.
Okay, the question, do you think isotope have same physical property or different physical property?
Different physical properties
Okay, why, Henrietta?
because they have different mass numbers.
Okay, good. Okay, you can see that they have different mass number. Okay, automatically, okay, the mass is going to be different. Okay, if the mass is going to be different, even if you look at the density, density is mass divided by volume. If your mass is different, density also is going to be different. So therefore, okay, isotope have different, okay, physical property. So please remember this. Okay, isotope. Okay, what you need to remember about isotope? Quite simple. Yeah, what is isotope? You need to remember what is isotope. Isotope is going to be any element that has the same proton, okay, but different neutron. Okay, different number of neutron. That is definition. Okay. But isotope also, okay, isotope have same chemical property because, okay, they have the same number of electron. Okay, but they have different, okay, physical property because, like, for example, okay, they can have different mass, okay, different density, okay, because their mass number or the neutron is going to be different. Okay, please remember these three. Yeah. Now, so if you have this, okay, you can see here chemical properties of isotopes. Okay. So if you look at this, okay, what can I say from here? Okay, these are the isotopes, okay, of magnesium. These are the isotopes of oxygen. How do I know that they are isotope? Okay, because they have the same symbol. Okay, but not only because they have the same symbol, I cannot simply say that they are isotope. Okay, because they have the same proton number. Okay, same proton number, but different, okay, mass number or nucleon number. Okay, so if they have different mass number, okay, they are going to be isotope. Okay, but now, okay, if I compare, okay, within here, okay, I told you they will have the same chemical property, okay, same chemical property, but different, okay, different physical property. Okay, different physical property, and this will apply, okay, for magnesium also. Okay, will apply for magnesium. Now, some students will be asking, you know, or wondering, sir, okay, if we have so many elements over here, does it mean all of these elements have isotopes? Okay, and why? Okay, this one to answer why, there is no answer to why. Okay, because in nature it exists like that. Okay. Does it mean all the elements in your periodic table has isotope? The answer is no. Yeah, the answer is no. Okay, there are some elements that they have the isotope. Okay, so for example, the common ones. Okay, the common ones. Okay, hydrogen. Okay, they have isotope. Okay. Just now, based on the example, okay, carbon has isotope. Okay, magnesium also have isotope. Okay, based on the example just now. Oxygen, okay, which is just now only. Yeah, we had oxygen as our discussion. It's also isotope. Okay, and then you can see magnesium also I already did. Okay, so all these they have isotope. Okay, Cl also have isotope. Okay, now this is the periodic table that you have in the textbook. Okay, but in your exams, okay, the periodic table that you will get is going to be this one. Okay, the one over here. This is the periodic table that you will get in your exam. And it is slightly different. Okay, especially, okay, when you look at this value. Okay, here, okay, 35.5, okay, and chlorine, okay, the mass is 35.5, okay, I think maybe in your textbook is actually error or what, okay, they maybe forgot to put 35.5, okay, the new textbook, okay, but it's not 35, okay, it's not 35. Okay, why suddenly you have 35.5? Okay, because okay, we normally learn okay like a number. Let's say for example, if I have hydrogen, okay, I have 1, I have 2. Okay, If I just want to find the proton number, proton is 1, electron is the same, okay, neutron is 1. I can find the difference, okay? It's all in the round number, okay? But if you have Cl, Cl is the 1735.5. If I want to get the proton 17, electron 17, neutron, why? Neutron suddenly there's 0.5. Okay, when I differentiate, why they have half or certain fractions of neutron? Actually, it's not a fraction. Yeah, it's not fraction. If you look at the number of neutron over here, okay, we have to consider, okay, this is not a simple what we call as mass number. Okay, this is what we call as an average. Okay, we take average from the isotope. Okay. So when it comes to isotope, okay, the mass, we have to take average. And the mass, okay, for Cl, okay, we have two types of isotope, Cl35 and Cl37, okay? And some students will think, oh, 35 and 37, why not just simply take in the middle? 35 plus 37 divided by 2, you get 36. Why not 36? Why must be 35.5? Now, this one, okay, if you have in nature 50%, okay, and 50%, okay, then you can divide by 2, okay? But in nature, it's not 50% and 50%. Okay, they are going to be different abundance. We call it, it is found in a different amount. Okay, so if it is found in a different amount, the way we calculate the average also different. Yeah, it's going to be different. So the calculation, okay, later we will look at it. Yeah, the next part. Okay, but generally, okay, you can see here. Okay, what we are going to generally look at is going to be this relative atomic mass. Now, relative atomic mass, okay, like for example, if you have carbon, okay, carbon, and then I have 6, and then I have 12, okay, what does it mean? Okay, it means that carbon, okay, is 12 times, okay, 12 times heavier, okay, compared to, like for example, let's say I just try to compare, okay. Let's say this person is 1, okay, and then this person is double the size or is twice as heavy compared to this guy number 1. So I just put 2. Okay, I put 2. And you have another person which is going to be, who's going to be 4 times heavier than number 1. So I will say 4. Okay. In the past, okay, it was very easy. Okay, when scientists actually found out, okay, now we compare, okay, we relative to each other. They use hydrogen. Hydrogen 1, the mass number of hydrogen is 1. So everything when we compare, like for example, carbon 12, okay, it means, let's say for example, another one, nitrogen 7 and 14. What does it mean? It means that carbon is 12 times heavier. Okay, 1 atom of carbon is 12 times heavier compared to 1 atom of hydrogen. I hope it's clear. Yeah. So if you have 14, okay, the scientists actually say, yeah, nitrogen is 14 times heavier compared to hydrogen. Now, later on, there was a problem. What is the problem? Hydrogen start to have isotope. They found out, okay, hydrogen have isotope, 3 isotope. Okay, now I cannot simply compare just like that. Okay, not suitable. Okay, can we remove hydrogen and replace with something else? Okay, so what they replace, okay, they try to replace with carbon. Okay, what is the problem with the carbon? Okay, carbon earlier is 12. Okay, it's 12 already. So what you need to do, okay, if you have carbon, let's say I put it as carbon here. So what you need to do, you need to divide carbon into 12 parts. 1, 2, 3, 4. You divide them into 12 equal parts. Now, we know this part, okay, this part can represent similar to hydrogen. Do you agree? One part, okay, because carbon was 12 times heavier than hydrogen, okay, each one. So now, what you need to do, you just need to compare to one part, okay, of this carbon, and that will be similar to hydrogen one. Okay, so you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what happens? Okay, they actually start to compare using hydrogen, but we take 1 over 12 of one atom of carbon 12. Okay, why carbon 12? Yeah, maybe some of you get confused. Carbon 12. Just take it as one atom of carbon. Okay, but later on they found out another problem. Okay, what is another problem? They found out carbon also have isotope. They say every single time we find new isotope, it's not practical to cancel all the time. So they say, okay, no need, forget about isotope. Okay, we put our foot down. We just focus on carbon 12. So they say carbon 12. Okay, that's why they say that anything, okay, is going to be referred to 1 over 12 of one atom of carbon 12. So what does this mean? If you have 14, what does it mean? Nitrogen, okay, nitrogen is 14 times heavier, supposed to be 14 times heavier than one atom of hydrogen. But you just need to change. Nitrogen is 14 times heavier than 1 over 12 of one atom of carbon 12. So same. Okay, you just need to times by 14. So that's the meaning. Okay, that's the meaning. So if you look over here, okay, AR, what is AR? Relative atomic mass. Okay, relative atomic mass. So it's going to be, what is the meaning? It's the average mass of the isotope. This is compared to 1 over 12 of the mass of carbon 12. Okay, that is the meaning if you put it in terms of sentence. Okay, so if I just compare again, yeah. Okay, if I take any elements in your periodic table, for example, xenon. Okay, xenon. Xenon is 131. Okay, xenon is 131 times heavier compared to Gianna. Compared to what? Can you complete this sentence? 131 times heavier compared to what? Jake, can you help over here?
1/12 of one atom of C12.
Okay, 1 over 12, okay, of the, okay, compared to the mass of 1 over 12 of one atom of carbon 12. Okay, that's the meaning. Okay, 131 times heavier compared to the mass of 1 over 12 of one atom of carbon 12. That's the meaning. Yeah. Okay, so okay, with that, okay, I will just continue here. Okay, you can calculate, okay, calculate what we call as, okay, the relative atomic mass. Okay, the calculation is going to be based on the abundance. Okay, and I told you, okay, YCl you have 35.5. Okay, because Cl is not 50% and 50%. Okay, it is not like that. Okay, if it is 50%, 50% easier. 35 plus 37 divided by 2, you get 36. Okay, so how to calculate? Okay, we follow this percentage is given, yeah. 75%, okay, they have mass of 35. 25% has the mass of 37. How to calculate? okay, you just need to put 75 over 100 times the mass 35. You put a bracket. And then 25% times the 37. So this is like a to find the average, okay, to find the average, okay, but using a certain ratio. Okay, when you calculate this, okay, you are going to get 35.5. And this is why, okay, for CL, we are going to get 35.5. Okay, why this one is 35.5? Because, okay, the abundance, CL 35 and CL 37. Which one is 25%? Which one is 75%? You can check again. Okay, the one that is going to be the 35, the closer to 35, they will be more. Okay, so it means that that is going to be the 75%. Okay, you can see here 75%. So I will write down here 75% in nature, CL is found in form of CL35. And 25% in nature, it is found in terms of 37. And if you find the average, okay, you will get 35.5. Okay, that's the meaning. And the same thing, okay, can be applied for hydrogen. Okay, but they didn't put because eventually when you count it's 1.008. Yeah, they just make it as 1. Okay. The same thing applies, okay, for oxygen, okay, but in the end also it will become 16, okay, they 16 point something, so they didn't put over that. The one that is very much visible, okay, to the to our eye is going to be this one. For chlorine, Y is 35.5, okay, because we will be thinking why neutrons suddenly become like 0.5. And the reason is because of the abundance, okay, because of the isotope. Okay, now let's continue further. Okay, check for understanding. Okay, what are isotopes? Kayla, can you tell me what are isotopes? The best way, yeah, again.
Isotopes have the same proton but different neutron.
Okay, any elements, okay, that has the same proton, okay, different neutron, okay, different neutron. So maybe Michelle, okay, Michelle, there are 2 Michelles, okay, let's actually call, I think one of the Michelle is not here yet. Dave, can you tell me, okay, name the 3 isotopes of carbon and then write the shorthand symbols for them. Carbon, how many? Carbon, how many?
3.
There are 3, yeah. So carbon 12,
13.
13, carbon 14. So you just need to put 6 over there. Okay. Then the 3 isotopes of oxygen, okay, can be written as this. Okay, name, state the number of proton and neutron in each of the isotope. Okay, so oxygen, okay, 16. So if it is oxygen 16, you just need to put 16 over there. Oxygen 17 and oxygen 18. Oxygen itself, you can look at the periodic table. Okay, it's 8. Yeah, proton number is 8. So if you want PEN, 8, okay, all of these are 8. Okay, only neutron will be different. The difference is going to be 8. The difference over here is going to be 9. The difference over here is going to be 10. Okay, so you will write down. Okay. Now, what does, okay, I will skip number 3. What does AR stands for? Okay, it stands for relative atomic mass. Okay, atomic mass. Which atom is used as the standard for working out a relative atomic mass? Last time it was hydrogen. Okay, but do not write hydrogen anymore. Okay, the atom that we are going to use as a standard is carbon. Be specific, carbon 12. Okay, carbon 12. Now, what does the R, okay, in AR tells you? The R tells you relative, okay, in comparison, okay? And then write the definition of AR and make sure you understand each part of it, okay? The definition of AR is going to be the relative mass in comparison to 1/12 of the mass of one atom of carbon 12. Okay, that's the meaning. Yeah. And imaginary element Z has two isotopes, okay, 30%, okay, 45, the rest have 48. Okay, calculate the AR. I know the bell is already rang. Okay, let me finish this here. Now, so this one, okay, is going to be, if you have, okay, two isotopes, 30%, it means 30 out of 100, okay, 45, you times by 45. And then the rest, it means 70%. Okay, 70% of it has 48. So if you want to find the relative atomic mass, you need to calculate this. Okay, can someone help me to calculate the AR for Z over here? Okay, if you have value, let me know. While you're calculating, okay, Jesse, can you tell me why both isotopes of Z reacts the same way?
Because the valence electron is the same.
Yeah. Or you can say because they have the same, okay, they have the same electrons, same number of electrons. No need to go so specific about the valence electron, okay? But you just say same number of electrons is okay already. Okay, same chemical property. Okay. So anyone calculated? Okay. This value, can you give me the value?
47.1.
Point?
0.1.
Okay. So you can see, okay, there is no unit, okay, because it's relative. Yep. So 47.1, okay, you will have a decimal over there because it's isotope. Yeah. So it means it's closer to 48 because 70% of it is going to be 48. So it's not going to be in the middle. Yeah, like 45, 48, it's not going to be in the middle perfectly, like 45 plus 48 divided by 2. Yeah. We have to follow the percentage. Okay. Anyways, okay, this is going to be the lesson on isotopes. Okay, hopefully you understand today's lesson. Okay, thank you everyone. Okay, see you. Okay, bye.